So another use for Grignard reagents is in acyl substitution reactions. Now, I'm mainly going to talk about esters in this video, but what I talk about here will be true for esters, anhydrides, or acid chlorides. So our Y here could be a chlorine. We said it could be the carbonyl group, which means we have an anhydride, or it could be an ester. And this is a basic two-step reaction where if we add a Grignard, here we'll use methyl magnesium bromide. We get an initial substitution to form ketone, but we already know that ketones are reactive with Grignards, and so we end up getting a second addition to form an alcohol. Now, as I said, the example I show in detail here in a moment will be using an ester, but the only thing that's different about an ester from either an acid chloride or an anhydride is the leaving group. The reaction will work exactly the same. However, this reaction does not work for amides. Why does it not work for amides? Well, amides will typically have an NH proton, and that NH proton is more than acidic enough in order to just protonate the Grignard and prevent the reaction from happening. In the same way that it doesn't matter for this reaction whether we're using an ester, anhydride, or acid chloride, it also doesn't make a huge difference as to what the R group is on the ester. So for this example, we'll use an ethyl ester, and then as our Grignard, we'll use an isopropyl Grignard. So that Grignard reagent will do a nucleophilic attack onto our carbonyl. That forms our tetrahedral intermediate. Tetrahedral intermediate breaks down through loss of the leaving group. And we form a ketone. Ketone, however, is not only still reactive to Grignards, it's largely more reactive. And so if the Grignard can add to the ester, then the Grignard can add without any problem to the ketone. And so we get a second addition of our Grignard. Which then, upon quenching the reaction, we protonate, form an alcohol, and get our product. And if you're wondering, can you stop this addition after one addition of the Grignard? The answer is that in general, no, because you're forming an intermediate that's actually more reactive than your original starting material.